Okay, so in this video, I'm going to be talking you through a few different topics that all link together. So I'm going to start with divisibility. We look at prime factor decomposition, then we look at the highest common factor and the lowest common multiple. So we're going to have a look at what divisibility is to begin with. Now, when you take an integer, and an integer is just a whole number, it can be positive or negative, it can even be zero. And if you divide it by a second integer, if there is no remainder when you do that division, we say that the first integer is divisible by the second integer. Now, it's usually a bit easier to show an example with this. So here's my first integer and my second integer. Because I can do 125 divided by 5 to get 25, I can say that 125 is divisible by 5 because there's no remainder when I do this. And so divisibility is thinking about what kind of divisibility checks, what kinds of things can I do that will help me see if I can divide two numbers without actually having to use a calculator. And that's the crucial thing. We're trying to do this check without using a calculator. Well, if I wanted to check if something can be divided by 10, all I need to do is to look at the last digit and I need to just see if it is a 0. For example, 170 ends in a 0, and it can be divided by 10 to get 17, so 170 is divisible by 10. For 2, you probably know this already, but if you want to divide something by 2, you just need to check if the last digit is even. So for example here, it ends in a 4, which means you can divide it by 2, so 484 is divisible by 2. And you're probably familiar with something being divisible by 5. That is if the last digit is either a 0 or a 5. If you think about the 5 times table, everything in the 5 times table ends in either a 0 or 5. So 135 divided by 5 is 27, meaning 135 is divisible by 5. Now I want to show you some other divisibility rules because it's quite useful to help you check for some of the stuff that's later on in this topic. So we've already dealt with 5, 10 and 2, but I want to talk to you about now the divisibility rule for 4. All you need to do is look at the last two digits of a number and see if that is divisible by 4. If those last two digits together are divisible by 4, then overall the number is divisible by 4. For 8, you look at the last three digits, and if they are divisible by 8, you may need to do a little calculation for that, then the overall number is also divisible by 8. This is where it gets a bit more interesting. So if you want to see if something is divisible by 3, you take its digits and you sum them. Sum means add together. Once you add together the digits of the number, if that is divisible by 3, then the overall number is divisible by 3. And for 9, it's the same thing. You take the digits of the number, you add them together, and if it's divisible by 9, then the overall number is divisible by 9. Now I'm going to come back to 7 and 11 in just a second, but 6 is a good one. 6, if the number is divisible by 2 and 3, it must also be divisible by 6. Everything in the 6 times table is even and in the 3 times table. And if you wanted to check if something was divisible by 12, well, you just need to check that it's divisible by 3 and it is divisible by 4. Now, let's have a quick look before we do 7 and 11 to check what this number that we've got here, 27,720, let's check to see which integers from 1 to 12 it is divisible by. Well, it's definitely going to be divisible by 1 because every number is divisible by 1. That's why I didn't put a rule there. So all we need to do for this, to check if something is going to be divisible by 2, is we need to look at the last number. Now, the last number that we've got is 0, so it ends in a 0, 27,720, and 0 is even, so I'm going to put a tick to say yes, it is divisible by 2. Now number 3, this is where we said for 3, if the sum of the digits is divisible by 3. Now the sum of the digits means you're going to take the 2, the 7, the 2, and the 0. We're going to add them together and see if that is divisible by 3. So 2 plus 7 is 9, plus 7 plus 2 is 18. And 18 is divisible by 3, so it is going to be overall divisible by 3. You could also take 18 and you could add the 1 and the 8 together, and you get 9, which is also divisible by 3. Okay, well, let's have a look at 4. 4 says that you look at the last two digits and see if that is divisible by 4. Yes, 20 is in the 4 times table. 20 is 4 times 5, so it's in the 4 times table. I'll leave that there. and so yes, it is divisible by 4. Is it divisible by 5? Well, we have 27,720. It ends in a 0, so yes, it is divisible by 5. Ends in 0, so it is divisible by 5. Divisible by 6. Well, by looking at our list for 6, it needs to be divisible by 2 and 3. It's divisible by 2 and 3, so it is a yes for 2 and 3. So overall, yes, it is divisible by 6. I'll come back to 7 in a moment, but I'm now going to have a look at divisibility for 8. Let's see if it's divisible by 8. It says the last 3 numbers must be divisible by 8. So we have 27,720. 720, is that going to be divisible by 8? Well, yeah, because we know that 72 is divisible by 8. So we can say that 720 is 8 times 90. So yes, it is divisible by 8. Now 9, the divisibility check says sum the digits and see if it's divisible by 9. Well, we actually summed these digits together before and we said that it was 18, and 18 is divisible by 9, so yes, this is going to be divisible by 9. Clearly with 10, it ends in a 0, so because it ends with a 0, we can say that it's divisible by 10. Which leaves us with just 11 and with 7 and 12, but we're going to do 7 and 11 separately. So 12, it says if the number is divisible by 3 and 4. Well, look, it's divisible by 3 and it's divisible by 4, so yes, it is. I'm going to do a tick for 3 and 4, therefore overall it is divisible. So let's have a quick think then about what this instruction means for being divisible by 7. We're going to explore the divisibility of 7 over here. It says if when you double the last digit and subtract from the remaining number, the result is divisible by 7. So our number that we have is 27,720. If when you double the last digit, well, that's not going to do very much, and you subtract it from the remaining number, the result is divisible by 7. So the remaining number that we have is this part. So we're going to do 2772, and from that number we are going to subtract this last digit doubled. That's what it says when you double the last digit. And when you double 0, you just get 0. So the answer to that part is just 2772. Now we need to tell if that is divisible by 7. But that's not very obvious. So what I'm going to do is repeat this process again. So I'm going to look at 2772. I'm going to take that last digit and I'm going to look at the remaining number, and I'm going to do 277. This time, I might just move that out of the way so that it's not quite in the same place. I'm going to be subtracting double 2, which is 4. So I'm going to do my 7 take away 4, which is 3, so I get 273. Okay, well, now I need to decide if 273 is divisible by 7. So I'm going to have a look at the last digit, and I'm going to double it and take it away from the remaining number. So there's my remaining number, and away from that I'm going to take double 3, which is 6. 27 take away 6 is 21, and 21 is divisible by 7. So I can say tick, it is divisible by 7. Now my last one that I want to have a look at is the divisibility by 11. Now I'm not sure I'm going to be able to squeeze this in, but we'll have a go. So for this one, you need to do what the instructions say, which is if the sum of the odd position digits subtract the sum of the even position digits is divisible by 11. So our number is 27720. Now when we number the digits, when we say where they start from, we always start from the units. So this is our first position, second, third, fourth, and fifth. So I'm going to write down the odd ones and the even ones, and I'm going to highlight them in different colours. So the odd ones are the first, the third, and the fifth. So that's a 0, a 7, and a 2. And what it says to do, it says if the sum of the odd position digits. So let's add together the odd ones. The 2 plus the 7 plus the 0 is 9. Now the even ones, which I'm going to highlight in green, that's the second and the fourth, because 2 and 4 are even numbers. So we're talking about the even positions, not the even numbers in the digits. we're going to do the second and the fourth. They are 2 and 7, which is 9. And it says, for 11, if the sum of the odd positions, which is 9, subtract the sum of the even positions, is divisible by 11. So I'm going to do 9 take away 9, which is 0. Now, is 0 divisible by 11? Well, it is actually, because if you do 0, if it's divisible by 11, yes, it is, because 11 multiplied by 0 is 0. So we can say that actually 0 is divisible by 11. So if you ever get a 0, that does mean that there's going to be a divisibility. So yes, it is divisible by 11. What I've done here is I picked a very good number that is divisible by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, in the next video, I'm going to do a couple more if you want to check about how to do division by 11 and 7, just for some trickier kinds of questions, in case you want to see how I do those. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.